So today's notes are called Intro to the Unit Circle. And like I said, this is where we are starting Module 3. And our target. I have a lot of lag time today. I know it's annoying and frustrating. I get it, but it's the best we got. All right, target. How do you use your knowledge of special right triangles? How do you use your knowledge of special right triangles to find the angle measure in the unit circle? And then how does this help us find the ordered pairs on the unit circle? Okay, y'all remember special right triangles from geometry? Anybody give me an example of a special right triangle? How about a 30, 60, 90? Huh? It's a special right triangle. It's a right triangle that has a 30-degree angle and a 60-degree angle, as well as a 90-degree angle. How about a 45, 45, 90? Remember those? Okay. Y'all remember SOHCAHTOA? Yeah? All right. So that's what we're doing today, some SOHCAHTOA. SOHCAHTOA is a relationship between the sides and angles of the special right triangles. And we have got to memorize these for the unit circle, okay? But before we get into the unit circle, we're going to do a little review on SOHCAHTOA. So first of all, I'm going to draw a right triangle. Right triangle means it's a triangle that has a what kind of angle? 90-degree angle, which we see here. What is the leg directly across from the 90-degree angle called? The hypotenuse. That's how I like to say it. Hypotenuse. I don't know why I say it like that, but it just comes out that way. Yes? Special delivery?
Yeah, I guess. Report card.
Oh, thank you. Maybe it's in here. And some kid I don't know. Thank you very much. Do y'all know what theta is when you're talking about triangles? Theta, by chance? Theta is in the Greek alphabet. It kind of looks like a 0 with a little loop through it. And theta, that is Theta, theta. Theta is talking, it means the angle that you're referring to at this moment, okay? Theta. So I drew my theta here in the bottom left corner. So if I'm referring to the theta, what would this side be called? You have your adjacent side, your opposite side, and your hypotenuse. We already labeled the hypotenuse, has nothing to do with theta. It's always the leg directly across from the right triangle, right? Okay, so if I'm referring to my theta, that's the angle I'm talking about, what would this side be called? Wait for it. Come on, hand. There we go. This leg, would it be the adjacent leg to theta, or would it be opposite of theta? Opposite. If it's adjacent, it means it helps form the angle, right? So what would that other leg be called in reference to theta? Adjacent. The hypotenuse, while it is adjacent to theta, it will never be labeled as adjacent. It's always just the hypotenuse, okay? If my theta was that other angle, not the 90-degree angle, but the other one, then it would be labeled differently, correct? Okay, so let's talk about SOHCAHTOA. When I say SOHCA, you say TOA. It's the only chair I know. When I say SOHCA, you say, you're all supposed to do it together. TOA. All right, tough crowd, man, this class. Oh, tough crowd. So SOH is the so part, and then ka, and then TOA. Is there anybody that's like, what in the world is SOHCAHTOA? What is she talking about? But have you heard of it, SOHCAHTOA? Like, even if you don't remember what everything stands for, you've heard of SOHCAHTOA, because you should have done this in geometry, as well as algebra 2. So SOHCAHTOA is what I use to help me remember how to find sine, cosine, and tangent of an angle, right? That sound familiar? Okay, so the SOH part, the so, is used to help you to find the sine of an angle. So the S, guess what the S stands for? Sine, and it's not S-I-G-N, it's S-I-N-E. S-I-N-E. What do you think the O stands for? Opposite. And what do you think the H stands for? Hypotenuse. So to find the sine of theta, you take the opposite leg and divide it by the hypotenuse. Okay, so how you would write that is, scoop my paper up eventually, sine of theta equals opposite, I'm just going to put OPP, over HYP. Opposite over hypotenuse. Opposite leg divided by the hypotenuse. So when I'm talking about sine, I'm talking about the relationship between the different measures of the legs, okay? So if I want to know the sine of theta, I just say, okay, what's the length of the opposite leg divided by the length of the hypotenuse? Which right now we don't know any lengths of legs, right? We're just figuring out what sine, cosine, and tangent is. Let's move on to C-A-H. What do you think the C stands for? Cosine, so that's C-O-S-I-N-E. And what is the A? Adjacent. and the H, hypotenuse. So to find the cosine of theta, take the leg that is adjacent to theta and divide by the hypotenuse. Okay, it's a relationship between the legs. So cosine of theta, COS is short for cosine. I should have said SIN is short for sine. I know the word sine is short enough, but it does have an abbreviation. So to find the cosine of theta, take your adjacent leg and divide by the hypotenuse. And then what do you think TOA is all about? What are we, when we're using TOA, what does the T stand for? Tangent. T-A-N-G-E-N-T. Tangent. To find the tangent of theta, you take the opposite leg and divide by the adjacent leg. So the abbreviation for tangent, anybody know it? TAN. So tan of theta, tangent of theta, equals opposite divided by adjacent. Now these special right triangles, the relationships between the legs, there is, how do I say it? If you have a 45, 45, 90 or a 30, 60, 90 degree triangle, if you just know the length of one leg, you can find all the others. Now, for that, there's not a special relationship between just any old 90 degree triangle. But if it's a 30, 60, 90 or a 45, 45, 90, if we know just one leg, we can figure out the lengths of the other legs because of SOHCAHTOA. Okay, there's a special relationship. You need to have this memorized. This is going to come up a million times during our trigonometry unit, and we have 2 units on trigonometry. Okay, so special right triangle relationships. Y'all learned these in geometry, so it shouldn't be anything new, even though you might not remember it. Special right triangle relationship. First, we're going to talk about the 45, 45, 90 degree triangle. If you have a triangle that has a 90 degree angle, and the other 2 angles are 45 degree angles, do y'all remember what that tells you about the sides? If you have a 45, 45, 90 degree triangle, so you have a 90 degree angle and the other 2 angles are the same, 45 degrees. Do you remember what that tells you about the sides? The 2 sides are what? The same. They're the equal. If your 2 angle measures are the same, then the 2 sides, not the hypotenuse, but the other 2 sides are equal distance, right? So let's look at a 45, 45, 90 first. So I'm going to try to make my 2 sides equal, because if the angles opposite of those 2 sides are equal, then the legs are equal. And I'm not going to use numbers for the most part. When I say S, that just means the length of the side, okay? So I know if my 2 sides are the same length, I'm going to call them both S's. Then we know that the hypotenuse is the length of one side times the square root of 2. So like say my side lengths were 5 meters, and the hypotenuse would be 5 square root 2. If my legs were 10 inches, Then my hypotenuse will be 10 times the square root of 2 whenever you have a 45, 45, 90. So we say S square root 2. Make sure mine kind of looks like a 5. Make sure yours looks like an S. Okay, that is a 45, 45, 90. That does not work for any old triangle or any old right triangle. It has to be a 45, 45, 90. So we said the other special right triangle is a 30, 60, 90. Okay, so you're going to have one short leg. So I'm going to put mine on the bottom. And the short leg, if you have a 30 degree, 60 degree, and 90 degree angle, the short leg is across from which one of those angles? Remember? Shortest leg is opposite the smallest angle. So my 30 degree angle is going to be up top. And no, my triangle is not perfect. So my 60 degree angle is down at the bottom. This is a 30, 60, 90. Like I said, 30, 60, 90, the shortest leg in a 30, 60, 90 is across from the smallest angle. So my shortest leg, the way I drew it's going to be down here at the bottom. And I don't know the measurements of any leg right now. So we're just calling the shortest leg we call S. So if I know the length of the shortest leg, it's the easiest. But really, you can know the length of any side and find the others, which I'll show you how to do. My shortest leg I'm referring to as S. The hypotenuse is twice as long as the shortest leg on a 30, 60, 90. So if the hypotenuse is twice as long as the shortest leg, in this example, what would we say to hypotenuse? How would we write that? Yep, S times 2, or we would say 2S. Twice as long as the shortest leg. So if my shortest leg is 10 centimeters, how long is the hypotenuse? 20 centimeters. The leg that's across from the 60 degree angle is the length of the shortest leg times the square root of 3. Shortest leg times the square root of 3. So if my shortest leg is 10 centimeters, my hypotenuse is 20 centimeters, and the middle leg, the leg across from the 60 degree angle, would be 10 times the square root of 3. Right? You need to have that memorized. So this is what I always remember. The 45, 45, 90. It had two of the legs are going to be the same, right? So 2 legs are the same, and then the hypotenuse is S square root 2. On the 30, 60, 90, all 3 legs are different, 3 different legs. So on that one, it's for the leg across from the 60 degree, it's S square root 3. Because you got to remember something square root of 2 and something times square root of 3. So I always remember the 30, 60, 90, they're all 3 different. So I know that one as S square root 3. And on the 45, 45, 90, there's 2 S's, and the other one's S square root 2, 2 different angle measures. That's how I remember it. That's how it helps me remember. And also we do it a million times over, and that helps me remember too. All right, so far so good? Okay. On the next page, we're going to draw a unit circle and put some definition-y type stuff down. And this definition-y stuff is really important for like the next 2 units. So this is not a good time for a nap. Taking notes in math class is never a good time for a nap. FYI. All right, so the unit circle. I'm going to draw a big circle, and it's going to take up pretty much like the top half of my sheet. And I'm going to do the best I can. It's not going to be perfect. And that's okay. I'm going to draw an X and a Y axis right through the middle of the unit circle. Does anybody know, do you remember when you're talking about the unit circle, the unit circle has a radius of what? Anybody remember? What the length of the radius is in the unit circle. Not just talking about any old circle, we're talking about the unit circle. The radius in a unit circle has a length of 1. Okay, we'll write that down in a minute. So if I want to know what is the ordered pair right here, if this is a length of 1, what would this ordered pair be? Remember, this is the x-axis, this is the y-axis. What would your x value be here? Oh, y'all can't even see, I'm sorry. 1. And what would your y value be? 0. And I know that because I know this is the unit circle, and I know the unit circle has a radius of 1. Let's go up to the top. What do you think the ordered pair there is? 0, 1. When your x is 0, your y is 1. We're going counterclockwise to that next point where my x-axis goes through the circle again. What do you think that ordered pair is? -1, 0. And then down at the bottom, keep going counterclockwise. What's that ordered pair? 0, -1. So those are 4 of your main ordered pairs on a unit circle. I'm going to teach you how to find a whole bunch of other ordered pairs on the other circle, on the unit circle, using those special right triangles, okay? But first of all, let's learn about our definitions of the unit circle. So first thing we're going to say is the unit circle has a radius of 1. That can be used to determine values of trigonometric functions. Another thing we need to know, the unit circle is centered at the origin. Theta is the angle formed by the positive x-axis and a ray that intersects the unit circle. This ray is called the terminal side. And I'll demonstrate what all these things are after we get all the definitions written. Okay? The angle measure is positive if the rotation of the terminal side is counterclockwise. Y'all know what counterclockwise means, right? So when you're looking at a clock and the normal rotation, the normal rotation of the clock hands goes, I know at home y'all can't see me, but it goes, I can't look at that clock and it goes this way, right? That's clockwise. So if you were to wind a clock back and you're going the opposite direction, that's counterclockwise. So generally in a unit circle, normally we're going counterclockwise. That makes a positive angle, okay? But you can go clockwise, and when you go clockwise, guess what? You're gonna have a negative angle measure, which is the next thing I'm gonna write. The next thing I'm gonna say is the angle measure is negative angle measure is negative if the rotation of the terminal side is clockwise. All right, one more thing to write. If the base of the right triangle is x, and the height is y. The ordered pair at which the terminal side intersects the circle is x comma y. And I'm going to go back up to counterclockwise, draw a little rotation so you know what I mean. Counterclockwise. You'll see it in a minute. Is like that, and then clockwise, like this. All right, so let's look at these things that we've learned and go back up to the unit circle. All right. So the first thing we said was the unit circle has a radius of 1. That can be used to determine the values of trig functions. All right, cool. We already talked about that. The unit circle is centered at the origin. All right, so we know what's that ordered pair right in the middle? 0, 0. Okay. Theta is the angle formed by the positive x-axis. So we know which side is the positive x-axis, the right side of the origin, right? Is formed by the positive x-axis and a ray that intersects the unit circle. This ray is called the terminal side. Okay, so I'm going to draw a ray from the origin to the unit circle somewhere in quadrant 1. That ray that I just drew, which it starts, one endpoint is at the origin, the other endpoint intersects the unit circle, that is called the terminal side. And I did not write a definition for the initial side, but the initial side is always the positive part of the x-axis, okay? Initial side is always the part. So that initial side always stands still. And that terminal side can rotate around the x-axis. It can rotate clockwise or counterclockwise. The initial side always stays where it's at. It does not move. It's stationary. But the terminal side, we can move that around the circle. If we go counterclockwise, it's a positive angle measure. If we go clockwise, it's a negative angle measure. And I know, angles, how do they measure negative? That's so weird. If you actually measure an angle, it does not have a negative measure. But that tells you, if you see an angle that's negative, that tells you that you went counterclockwise or clockwise, okay? You can't actually measure an angle and it's negative. It just tells you the direction that your terminal side went. If the base of the right triangle is x, okay, so what we do to help us find ordered pairs on a unit circle is we go to where that terminal side intersected the unit circle, okay? And we draw a line straight down to the x-axis, straight down. That's going to create a right angle. You never draw it to the y-axis. It's always drawn to the x-axis. And when we create that right angle, we'll be able to find the ordered pair of where the terminal side intersected the unit circle. That's going to be x comma y always, right? In this case, to find your x coordinate, that's going to be the distance from the origin to the end of my triangle, right? That's your base. So x comes from the base. And the y coordinate, won't that be the distance it is? The distance it is here? Like, where is this on your y axis? So if we know the distance it is from the initial side up to the unit circle, won't that be the same distance as from the origin up to the y-axis if we were to draw it over? You know what I'm saying? It's so hard with all this lag time for like you to see exactly what I'm talking about. But you would always find the y, in this case, would be the height of this triangle. Because the height of the triangle is the same distance as it is from the origin up on the y-axis. It's the same distance over. Do y'all see what I'm saying? That is if theta is the angle formed by the initial side and the terminal side, okay? Which that's always going to be the case in the unit circle. Theta is always the angle formed by the positive x-axis and a ray that intersects the unit circle. We can't always use theta to find the x and the y. Sometimes we have to use a reference angle, but we'll get to that. Okay? Now, I'm not going to be able to get too much further today, but we can still go forward. I'm going to have to divide today's notes into 2 days. Okay. My next page. There is no assignment today, so that's good news. And we had 2 days off this week. Next week is a whole week. We go every single day, no early release, no days off, no nothing. But the following week is Thanksgiving. We don't have school that week, right? The whole entire week. All right. The length of the hypotenuse formed in the unit circle is 1. The length of the hypotenuse formed in the unit circle is 1. Because think about it, that triangle that I just drew, the hypotenuse was the same length as the radius, right? So only in the unit circle is the hypotenuse always going to be 1. If you're not talking about a unit circle, the unit circle or the hypotenuse is not always 1 for just any old triangle. But if you're talking about the unit circle, the radius in the unit circle is always 1. So the hypotenuse of any triangle drawn in the unit circle is 1. Okay? Super important point. Now we're going to write the trigonometric functions. Write the trigonometric functions for theta in the unit circle. Write the trigonometric functions for theta in the unit circle. So they're talking about sine, cosine, and tangent. Whenever I do sine, cosine, and tangent, I always write SOHCAHTOA. I don't need to write it all out because I know what the S, the O, the H, the C, the T stand for. But I always write it so that I have it right there so I can reference. Like, oh yeah, cosine is adjacent over hypotenuse. Tangent's opposite over adjacent, or whatever it is. And I'm going to draw a small unit circle over here on the right with my x-axis and my y-axis. And I'm going to draw a terminal side somewhere in the first quadrant. And I'm going to form a right triangle by going to the point where that ray intersected my circle, and I'm going to drop a line straight down so that it forms a right angle with the x-axis. So my theta is the angle formed with the positive x-axis and the terminal side. And we said on the previous side that the base would be your value of x, right? Your x coordinate. Your height would be your value of y, the y coordinate. And what did we say the length of the hypotenuse was? 1. So right now, that's the only leg that we know the exact value of. But in the unit circle, if we can form a 30, 60, 90 or a 45, 45, 90, we can find the other legs just by knowing SOHCAHTOA. Okay? So we're just going to use what we know in this triangle. Okay, y'all with me? So first, let's find the sine of theta. So the sine of theta, we know sine of theta equals the opposite leg over the hypotenuse. Opposite over hypotenuse. OPP over HYP. So in this unit circle, what is the measure of the leg opposite of theta? Y, because the leg opposite of theta is Y. What's the measure of your hypotenuse? 1. That's all we know, right? Well, what's Y divided by 1? Y. So we just say in a unit circle, this is not any old triangle, okay? This is only a unit circle when the hypotenuse is 1. In a unit circle, we say the sine of theta is equal to whatever your Y value is, whatever the height is on that triangle. That's your sine of theta. So if you memorize that, it's pretty easy. If not, just do opposite over hypotenuse, and you're always going to be like, oh yeah, the hypotenuse is 1, so it's whatever Y is. Let's talk about your cosine of theta. And we know cosine, because of SOHCAHTOA, is the adjacent leg over the hypotenuse. Adjacent over hypotenuse. So in this generic unit circle, we don't know any measurements except for the hypotenuse, right? What's the measure of the leg adjacent to theta? X. And what's the measure of the hypotenuse? And x divided by 1 is just x. So when we're talking about the unit circle, and I say, what's the cosine of theta? All you have to do is figure out what's your x value, and that's going to be cosine. And then to find the tangent of theta, tangent is the opposite leg over the adjacent leg. What's the measure of the leg opposite of theta? Y divided by, what is the measure of the leg adjacent? X. So for tangent, that doesn't reduce to just one variable. You have to find the leg that's opposite divided by the leg that's adjacent. All right, and I want to get this next little thing out. I can do it in 4 minutes. Okay, pretty quick. So on the bottom of my page, I'm going to say, we can use these trig functions to find ordered pairs in the unit circle. We can use these trig functions it'll ever pop up. We can use these trig functions to find ordered pairs in the unit circle. And then the room that I have on the rest of the page, I'm going to draw one more unit circle. I'm going to draw an x-axis and a y-axis. And y'all know your quadrants, right? What do I call the quadrant in the upper right corner? That's quadrant 1. What about upper left corner? 2. See how it goes counterclockwise? What about bottom left? 3. And bottom right, 4. So it's helpful to know, okay, in quadrant 1, all of your x values are positive and all of your y values are positive. Is that right? Right? Any ordered pair that I found, any triangle, your x's and your y's are positive. Don't even think about that circle around it. Don't let that confuse you. But if you were just graphing something, any ordered pair in quadrant 1, your x's would be positive, your y's would be positive, right? This is just going to be helpful when y'all start finding ordered pairs. Because a lot of people, they get it right, except for they mess up the sign. So any ordered pairs you find in quadrant 1, your x should be positive, your y should be positive. What about quadrant 2? Is your x positive or negative? Negative. What about your y? Positive. Quadrant 3, your x is negative and your y is negative. Quadrant 4, your x is and your y is boom. Next class, we'll do Intro to the Unit Circle Part 2, and we'll actually start finding some ordered pairs, okay? We had to get all that down before we could do that. So everybody at home, lunch bell's getting ready to ring. Y'all can log off whenever you want to. I'm going to end the video so I can start converting it so I can get it uploaded and posted on Schoology. There's no homework, and I'll see all y'all on Monday. Have a good weekend. Everybody in class, see you after lunch.